Okay, I'm just gonna try. What I did was I put a quick little is it SOT 23 MOSFET between gate and source on the MOSFET on the low side MOSFET, and then I run the high side trigger to the little tiny SO23 trigger, or to its gate, from the high side, from the input side of the driver chip. We're just going to see what this looks like here on the scope. Actually, it looks really good. There we go. I think I got it. So, let's just look at this. You can see this is actually, man, I thought I didn't have it because I hooked the ground lead of my scope to the wrong place, and I had a big ring. So right here you can see a little line. This yellow line is the gate for the high side. That's the trigger for the gate for the high side. So you can see it turn on. You have your you can see the low side. This is the actual gate on the low side MOSFETs. This yellow trace is the actual high side signal right from the brain. So you can see the low side gate discharge. Then you can see where the high side gate actually, obviously this is where the signal comes on, but it takes from there to that ring there that much time, which is basically so this is a measurement, and this is one of the things Lebowski's bugging me about, is how long it takes for everything to turn on. So that's where it actually starts to change the what do you call it, the actual phase wire starts to move. So it takes about 720 nanoseconds. So you can also see it there on the low side gate. It shows through a little bit, but you can see my new little clamp saves it. Let's just see what I can do here. I just want to measure it. I hate that. There we go. So let's bring that up. So I'm around 2.4 volts, something like that on the, let's see, source. I want to bring that up a little bigger so it's a little easier to see. So it's about, yeah, we're about 2.2 volts, I would say, as a false trigger. Now these little SO, I'm going to unhook this because it's definitely not safe. Like, only actually set up one, it's cold as hell in here, my nose is running. I only actually set up one of the, and I've also got one of the low side gates on one phase. So these other two phases are not protected. But what I've done, what I'm going to do is I'm going to make a little circuit that comes off the high side gate trigger, uses proper 5 volts, so it's not screwing up the high side gate, but I'm going to try to make sure it's quick. I'm going to probably research some better FETs for this. These ones are maybe okay. You can almost see it in there. I have a light here. You can see it buried down in there under the wires. I got a big mess of shit going on there, so you can see the little son of a bitch down in there. Anyways, it's a big mess, but it's just for an experiment to see if I could get it to work. Those are my 10, I believe it's 10 NF caps that I put from gate to source. No, they're actually, you know, with the long legs, that's definitely not going to help either. But I think I finally solved my one problem. Man, I drove almost home and I realized I had my ground probe from this ground lead that I was testing with hooked up to the actual bus bar, but I actually had to hook it right up to the source of the MOSFET to get a true reading, and it was a lot better that way. Everything looks good, so I think I'm going to develop that in the next few days. These aren't them. I'm just going to grab the package so I can believe these are them. So these are what I hooked up in there. So it's a N-channel MOSFET SOT23 package. these things have 3 ohms RDS on. So, you know, that shows that with a 3 ohm MOSFET, I'm sure I could get something, you know, and that's only running 5 volts to the gate of it to save that ring there. I should probably take that off tomorrow. I think that's what I'll do. I'll save this waveform, then I'll take that off tomorrow and just compare the readings, because I haven't done a proper measurement with those caps on there either. But things are looking good. I think I should be able to get this to work.